So we start with the what do you need to take into your mind when you're designing an IG unit composition? First, where to start? Well, obviously, we start with the visuals of your glass, along with energy performance, meaning the first three. Solar control, U-value, and how do you want your glass to look like. That is basically affect the choice of glass. And then we will be thinking about what is the IG unit size? Does it have any safety or security requirement? I mean, from inside, from outside. We need to consider the loads, and we need to consider the facade design, whether your IG unit will fit to this profile system with all of this thickness, weight. Also think about the cost, of course. And the cost is not like a direct cost of the glass. It's also highly dependent on your IG unit composition overall. I've been talking it in detail next time. And if you get any special features like step glazing, silk screening, ceramic print on your glass, that will be affecting IG unit formula in many ways, especially if you have any type of coating there, but that's the subject for a further discussion. Today, we will briefly remember about first 3 points, and main focus will be on what loads are affecting IG unit, how do you calculate them, how do you take them into account, and basically what are they and where to look. Okay, enough for me, enough introductory words from me. Let's go to the meat of it. When choosing the visual look of your facade, the basic parameters is 3 characteristics: light transmission, light reflection, solar factor. I mean, level of light. So if you want, the first decision is, do you want a transparent facade or non-transparent uniformous facade? That is again highly dependent on your conditions of light, because an example on the left, this facade is very transparent with a lot of light falling on it, but still, depending on the level of sun, you either can easily see through the facade, or you will be having some reflections. So for example, here on the picture, this part is of the facade is directly under sunlight, and this part of the facade is under shade. So depending on this, you can look through, or you will be seeing mostly a reflection. Then this is, mind you, this is a very transparent glass. This is Suncool 7035, so 70% light transmission. On the right, your facade have much darker glass. So here light transmission is 70%. Here it is 40. Yet you can look through. Why? Because the sun is behind the building. And the level of light inside the office and on the viewpoint of you, the viewer, is more or less the same. So here, with the much darker glass, you see through the facade, while here, you have some difficulties in this part. Okay, but I've been touching all of this in detail with examples. So depending on how do you visualize the look of your building, choose the glass with a combination between light transmission, light reflection, and take into account local solar insolation in terms of how much light you will be having on this one. Another one is again about light reflection. So very reflective, very uniformous facade. Again, go for a darker glass. If you want your facade to be more transparent, go for more transparent glass. But remember, the more light transmission you have, the bigger difference you will be having between transparent and non-transparent zones. So if you have a very transparent glass, you will never create a truly uniformous facade. What are the disadvantages of high reflection? You know it. It's that if you have any glass distortion, any kind of glass distortion, there you will be seeing it in the reflection. So the more reflective the facade is, the more possible distortions for you to see. How to counter it? With the careful design of the facade, of the IG units. By carefully choosing the formula, like going for a thicker glass, thinking about glass bending under different loads, you can create a very uniformous facade even with highly reflective glass. Again, some examples. So on the picture to the left, very transparent glass. And you clearly distinguish between transparent and non-transparent zones. That is not good, that is no bad. It's all depending on how do you visualize your building, or architect visualizes the building. He could make like a green glass with the orange enameled zones. So if it suits him, yeah, go ahead. So just a reminder, light transmission, light reflection on all of the Pilkington products. So we have again, from a very transparent and very non-reflective glass, 10% reflection is almost twice less than your normal float, the IG unit with the normal float, and up to a very silverish and extremely reflective one. So options are yours to choose. Feel free. What else? Then you need to think about the degree of the solar control that you are required. Why is that important? Not only because of your energy saving, not only because you will save a lot on the air conditioning. That is a huge feature, but that's the most obvious one. What is not really an obvious is that from the visual point of view, if your solar control properties of your facade are inadequate to the level of solar energy falling on it, you can have a change of a visual look of your facade. See the picture to the left. I have been showing it also already. This is not glass. This is not some kind of optical distortion. This is aluminum foil, which is glued to the IG units from inside of the office. So what happens if the level of solar control is inadequate? Option A, people starting putting in more air conditioning, okay? And option B, they will start protecting themselves from the sun by using aluminum foil, blinds, and whatever internal solar control device they will come across. And that will change the visual look of your facade in a manner which can be shown here. Again, if you are going for a very transparent facade with high light transmission, and people will stack a lot of blinds in the office building from the inside, and mind you, all of these blinds will be of different color, different shape, I don't know, different manufacturer, and they will all look different. So in this case, your facade will be looking like a chessboard with the different with the squares of a different coloration. Well, so solar factor. Another option. If you are going or advocating for a glass with the low solar factor, the thing is that if your building will be having lower solar heat coming in, your spending on air conditioning equipment can also be lowered a lot, because obviously you need less powerful equipment to cool down the whole building if you have less heat coming in. That is also a point of consideration, and also can be presented to a owner or a design company as a bonus, as a benefit. Of course, I would advocate for our glass, but for that, I would need to explain why our glass is good, or soft-coated glass overall is good. Because with the soft-coated glass, you can make, with the soft coating, you can make the glass selective. I will not stop this a lot. But selective, what is a selectivity? Is when your glass transmits a lot of solar light, the visual light, which we are seeing, and it will reflect back a lot of solar heat, which we do not see, but which is used to heat up our building all the day, especially in the southern region. So our glass is designed in the way that it will transmit a lot of light and reflect a lot of heat. If you look at the numbers, you'll see that light transmission is almost always about 2 times higher than solar factor for each glass. That is what double silver coatings are doing, and that is why they're called selective. Last bit of advice about solar control. On what you're going to base your solar control properties. It is either A, you will be having some document or a calculation from, I don't know, facade consultant or green building consultant, stating that in order to achieve an optimum energy performance, solar factor or shading coefficient should be at this level or below. Then, yeah, you just basically choose the IG unit composition and go ahead. In case you don't have such a calculation, then base your solar factor choice on your knowledge. But think about this: if you're looking if you're living and working in a close to equator, or closer to equator than Russia is, the closer to equator you are, the more energy is falling on horizontal surface during the day, and less energy is falling on the vertical surface. So pay a special attention, take a special care when you're designing something of a glass roof, or I don't know, something with the vertical glazing. There you have to use glass with much lower solar factor than usual, because the amount of heat it will be stopping would be much higher. Question: if the certain glass marks have been specified, I mean glass trademarks have been specified for a project, do you think it is possible to replace with any of alternative products, AGC, Guardian, NSG, Saint-Gobain? I would advocate for NSG or Pilkington. Yeah, and the question goes on. How fixed are the specifications marked? Taking about solar control glass, what is your experience? My experience is that it highly depends on which stage are you trying to replace the glass with alternative product. If the stage is too late, like you've come with your suggestion when all of decisions are made, when all of the mock-ups are being made and observed, then it's close to impossible to replace one product with another unless you do something extraordinarily. The best thing, of course, is advocate for your glass. It's at the design stage, and the earlier you're entering it, the better. Because if you propose your glass or your glass composition at a very early stage, you are set in. The rest of the question of price, politics, friendship, and so on. But on the early stage, even if all the odds are for you, there is some kind of people inertia, because when you have, okay, let's imagine. So before you have four types of glass, you have seen the mock-ups, you already calculated everything, you chose the one that you like and wrote it down. And then somebody comes, hey, use my glass. From your point is, oh, I don't want to repeat the whole procedure yet again. No, it also depends on the human factor. That's my experience. Highly depends on whom you are approaching. I mean, you can approach consultant, you can approach the building owner, you can approach architect, from all of the different sides. And depending on this, you're building your strategy, you're thinking about how to promote your glass. And yeah. I think the topic is too big to be wholly discussed. But thanks for the question anyway. Right. So I'll advocate for Pilkington glass products, not because I'm working for Pilkington, obviously, but because the characteristics are rather good. And for the solar control is the top priority of our glass, because that's the way it is made for. That's its main purpose. So to finish up with the solar control, again, if you're using something for the roof over top glazing, consider lowering solar factor, I would say about 1.5 times at least. Example, if you have specified something like 40 or less solar factor for your vertical glazing, for horizontal glazing, I would go for at least 25% instead of 40. Because yet again, for the roof, it is much more important, because you will be having much more solar heat on the vertical surface, on the horizontal surface than on the vertical one. Okay, done with that. Consider U-value. U-value is important not only for the cold climates, it is very important for hot climates. Because what is a U-value? U-value is a heat transfer, thermal transmittance. So how much heat, what is the power of the heat flow, coming through 1 square meter of your glass or IG unit at a certain temperature difference between inside and outside. For an IG unit, it really does not matter whether it is in Russia, like we have +20 inside the building and 0 outside. Temperature difference, 20 degrees. Okay. If we go to, I don't know, Singapore, and we have plus 20 inside and plus 40 outside. The amount of heat would be the same because the temperature difference is the same. So do not disregard a U value as an unimportant factor for a hot climate. It is important. And believe me, if you're planning to glaze your building with just laminated glass with the U value of, I don't know, 2.8, and then you will replace it with an IG unit, you will have huge energy saving because of that. U value is very important also. But we will touch this in detail in the third part of the design, because there we'll be coming close to the calculations and looking how much energy and money can be saved with a proper solar factor and U value. And we'll go with the comparison of the different compositions. And U value for all of our products, very good. This is a U value for a double IG unit with argon filling. And do not disregard argon. Argon is also help you to improve your value by quite a margin. Okay, I hope I didn't bore you with the repetitive things that we have been talking about before. If you got any questions, please let me know. And now we're coming to the loads and calculations. At first, let us see what kind of loads can affect the IG unit and what kind of loads can we calculate using a special program, special software. At first thing which is coming to mind is the wind load, ever present all the time, especially if you're talking about high-rise building. Climatic loads, what is that? It is when, basically that is the force which is causing you lens effect. That is the temperature difference, pressure difference, or a height difference between the time and date of IG unit manufacture and the present conditions. Because you make an IG unit in a controllable environment in your factory, temperature is 25, 30 degrees, atmospheric pressure is okay, some certain atmospheric pressure, and then you're assembling an IG unit and sealing it all on the perimeter. So the conditions, the gas inside the IG unit will be having exactly the same temperature and the pressure as it is outside. And because IG unit is sealed, the amount of gas is fixed for a lifetime of an IG unit, of course. Then you go install it on the facade. IG unit will be heated by the sun. Gas will be heated and expand. Or alternatively, in the Russian conditions in the winter, it will be very cold. So gas will shrink and glass will bend inwards. So all of these, the change of pressure, temperature, will affect the gas inside the IG unit, and the gas will be pressing the glass inwards or outwards. That is a climatic load because it changes because the climate around the IG unit is changing. Climate loads are ever present there. Afterwards, you will be having a snow load. Now, obviously, for countries like Thailand, Singapore, you don't have any. But for Russia, believe me, quite an important thing. And afterwards, you will be having a special load cases. Special loads is like human impact. So if anybody wants to jump outside of your skyscraper through an IG unit, the calculation can tell you whether he will succeed or not. Most often not, of course, but and here is this is the picture of an example of this very calculation. This is an emulated a test for a soft body impact, and yeah, it also can be calculated. And the picture to the right is the computerized model of your wind, which can affect the buildings you see here. What other special loads are? If you have a glass roof and somebody will walk on it, will it be sufficient to hold the person or persons? And all other different types of loads, which will go under special case. So most important are wind and climatic. For cold climates, snow load have a huge importance for horizontal glazing. And special load cases, if they're present, can be calculated. So that is about load. Now let's see some pictures about each load individually. This is a photo from the Russian city of Yekaterinburg, where high wind blew off part of the facade. So tear it away from the facade. You may have noticed that this picture was taken immediately after the hurricane. And what is interesting here? So, as a common knowledge, you have a facade, you have your wind. Wind is blowing at the facade, at the IG unit, and pressing it inwards. And here, nothing inside, everything is outside. The thing is that if you are taking into account wind loads, then most critical wind loads actually not those they are pressuring the IG unit, but those that are tearing it away from the facade. So negative loads, that's so-called. Why they're happening? Let's see the picture here. And you see all of the buildings have corners. And around the corners, you may be seeing these blue zones. And these blue zones are areas with the negative wind pressure. So if the wind is blowing around the corner and suddenly the force increases, the wind stream takes out the wind from neighboring areas and you get a negative load. So suction. And it can tear away your glass from a facade. These types of loads are usually very high. They are the highest. And this type of loads is a very interesting thing because they have a duration, very short duration, 1 or 3 seconds. So keep that in mind, that peak wind loads are having short duration. So they're something like this. So here, exactly what happened. You see the corner. So wind load sucked the part of the facade away and out on the street. Remembering that, let's go further. Climatic load. Well, why is it happening? I've already explained. So this is a change of pressure and volume of the gas inside of an IG unit because of changing climatic conditions. How can you counter it? Also, usually you do install outer glass thicker than your inner glass. And about some specifics. Also, next webinar, we'll be talking about glass thicknesses. If you have a non-tempered glass and your IG unit is breaking because of the climatic load. One remark. If you do not have an IG unit, you have just a plain, simple, single glass, whether it's normal glass or laminated glass, single glazing. That means you do not have any gas inside of an IG unit. You do not have an IG unit at all. That means that climatic load does not affect a single glazing in any way, because you don't have a gas in the camera. That's quite easy, but not obvious for some people, as I found out on the previous webinar. If your glass breaks during the climatic load, the breakage pattern resembles an hourglass with the sand inside. And the more breakage lines you're having, the heavier was the load under which your IG unit finally gave in and broke. I don't know, for Russia, climatic loads are a very common occurrence for a residential market. What about your countries? Yes, of course, the main occurrences are on residential part, because if you're on the commercial buildings, usually you're either using tempered glass or you are calculated the load well in advance and you're safe from it. So this is not a common occurrence in the architectural projects. No. This is a climatic load. Snow load, a real life picture. In some Russian regions, you can have that much snow in just like 3 to 4 days. So now you understand why the snow load is important. Because if you had that much snow, it weighs a lot. I will not be stopping on this point here, but the snow load is calculated for the horizontal or close to horizontal surfaces at the usually 30 degree or less to the horizon. And human impact. A very special case when somebody is jumping on the glass and impacting it. And no, this is not possible in real life unless you have a conish head or something like that. And this can also be calculated upon the special request. Why I am stopping also on these ones? Let's take a little bit back. So, wind load, short duration, very high force. Climatic load, what kind of duration does it have? Not a short one for sure, because climatic changes, climatic conditions around IG units changing slowly. So it has a lot of time to react and adapt. Snow load, also a very long one. And human impact, also very sharp one. Take this in mind because it will be important later. After we have seen the loads, we need to think, talk about what exactly are the results of the calculation. There are two types of results. So you have a program, software, you're inputting in like IG unit size, all of the loads which can affect it, from which side, you determine IG unit composition, and then you press calculate button. As a result, you will be having two numbers for each glass. One number is maximum stress on the glass, and the second number is maximum bending on the glass. So stress and displacement. First, the stress. This is the ability of the glass to withstand the load before breaking. As you can see in the table, every type of glass have different maximum stress with which it can withstand before breaking. So this is numerical representation of how strong the glass is. And as you can see, normal float can withstand something of 18 Newton per square millimeter, while tempered glass have much higher ability. That's why we are valuing it a lot for its durability. Heat strengthened glass is something in between the temperate and normal. And laminated glass is only a marginally higher than normal float, simply because interlayer, which connects these two glass, gives it better ability and better stress, better ability to resist loads and better maximum stress. The question goes, from which standard those numbers come from? Now these are coming from the, okay, let me write it down because the document says ETRLV. I believe it's 2016. And this is a standard for a Deutsches Institut für Bautechnik, German Institute for Building Thickness, building physics, I mean. Okay, I'll try my Deutsch. Deutsches Institut für Bautechnik. ITRLV, I don't remember that. So this is, do you see what I was typing? Yes? Why we're using these parameters? Because the calculation software with which we're using is MEPLA, SJ MEPLA. It's SJ MEPLA, calculation software. Software. They are using these and the methodics of stress calculation based on this ETRLV, on this document. So if you are using one model of static calculations, you have to adhere to the guidelines which are stated in the corresponding calculations methodics. So these are the place where these numbers come from. Does these numbers vary with different thickness of glass? No, they don't. Next question would be why? Because these are very interesting numbers, actually. They are derived from the, not only from the stress which the surface of the glass may withstand, but also to take into account a little bit of the glass edges, which are rather important. So, and of course, thermal treatment changes the surface parameters and changes the surface stress. And this is mainly the surface stress, which the glass can withstand on the surface. And that is why it is really no difference what is the glass thickness. Okay, I am removing everything about Deutsches Institut. So this is the maximum stress. So you have put it everything into the program and calculated it. And then you see each individual glass and see what is the maximum stress which has been calculated. If the calculated stress is lower than the maximum stress for this glass type, you're good. If not, do something. Consider a replacement. So first, what we are calculating is stress. Second thing which we are calculating is glass bending. So how much the glass will move, the center of glass will move under the given load conditions. Sorry. The thing is that some of people are used to see these numbers, I mean displacement or bending, as numbers representing how the glass will be bending under normal conditions. And here I must say something about which type of loads we are using. Usually, for the most calculations, you are using maximum worst load combination. So combination of maximum wind plus worst climatic conditions that can happen. So maximum expansion or maximum shrinking of a gas inside the IG units. You combine these loads and then make a calculation. For a wind load, you taking the wind, imagine this, you are taking the wind which is happening in this area once per 50 years, so twice a century. Quite rare. And your glazing may never see this load in its lifetime. But you're taking it as a precaution, so it will withstand any hurricane, anything else. Why am I focusing on this? Because of the following. For not all parameters are important or needed when you consider the your loads when you're making a calculation. Let's take an example. You are calculating this. So peak loads, maximum wind, worst climatic. What is important for you within this calculation? Stress. Whether your glass will hold or it will break under those conditions. And you need to have a formula, your combination, which will stand. What about the displacement, glass bending? Is this important, this condition? No. Because it doesn't give you any ideas. If you have a wind like this, you will not be going outside and checking whether your facade has some distortion or not. You will be covering somewhere because there will be trees, dogs flying around you. Look at those guys. And imagine him checking the bending on the facade. Not going to happen. Okay. On the contrary, if you have a climatic loads, for the most part, you will be looking at how your glass will behave itself. If you take only climatic loads, you will be seeing how much distortion, how much length you will be having on the facade. Climatic loads, usually the most important thing which we'll be looking at is bending, not the stress. And now try to remember about what I've been saying about load duration. Peak loads, peak wind loads, very fast, very sharp. So load duration is almost instant. Climatic load is long time load. Okay, already I think you have started to see some system in it. Human impact, very sharp load. Again, it matters what would be the glass stress. It doesn't really matter a lot how much your glass will bend while reflecting someone back into the office space. Short time load, and you have a similarity with your peak wind load. Snow load is a very special case, simply because glass is positioned horizontally or close to horizontal position. And this, yes, this is a long time load like the climate, but there the bending and the stress are equally important, because your glasses they should not touch each other, and there's bending, very important, the displacement. And of course, they should not break under stress. So you see, depending on the load type and load duration, you have some system about what parameters are more important than the others. I hope I was not being too mythical about this. The question, do you mean we need to combine the positive and negative pressures for the calculation? No. I mean, you should take the worst. I'm thinking about how to answer you like briefly. Okay, let's imagine that you are having your high-rise building. You have maximum positive load. Here is your IG unit. So maximum positive load, this is one case. You have maximum negative load, so suction, second case. And you have your climate. This is third case. So what do you need to do is you need to have combination of 1 plus 3 and 2 plus 3. So combination of positive pressure plus climate loads and negative pressure plus climate loads. You should calculate them both and then choose the worst one. I mean, more severe, where the combination is worse for your glazing. So that's how you should proceed. You need to calculate them all, and then for the show to someone, simply choose the worst combination for an IG unit and you're free to go. Okay, let's finally take a look at some calculation examples. So for ease of understanding, here we got an IG unit. Here we got an axis, so plus meaning inwards, minus meaning outwards. I'm talking about deflections. Let's take a look at the calculation of these square IG units under combination of wind plus climatic load and under the combination of climatic load only. This is a real case. And this is a very interesting thing that where you can evaluate how double IG unit and triple IG unit behaving differently. So if in the left part there are stress calculation, here is all of the stress is very low. This is the case of the cottage in the Mediterranean area. So not exactly a strong wind for a cottage. So loads are, even for the worst part, any type of glass will do. But take a look at the deflections. The thing is, if we're taking the worst load combination, so wind plus climate, then, and remember, if we take a look at the deflections, we are considering, we are thinking about how the glass will look like from a perspective of optical distortion of outer glass. See here, double IG unit, maximum deflection 5 mm outer pane. For triple IG units, maximum deflection is 1 mm. So we're thinking about, then triple IG unit is better in terms of visual deflections. And afterwards, we are going to calculate climate loads only. And here, the picture is reversed. Because if we do not take any heavy wind into the account and see how the IG unit will behave itself in case of only gas expansion or shrinking, then suddenly we are seeing that triple IG unit is worse than double. Does anybody have an idea why is that? Too difficult. Yeah, okay. Let's see it this way. What kind of climate is in the Mediterranean? Obviously a hot one, so IG unit will expand. Let's take a look at the double IG unit under climate loads. Very thick outer glass, 10 mm, and laminated glass of 2 × 6. For those of you who have been attending my previous webinar about lamination and acoustic, remembers that if you have a PVB film, that under long loads, PVB glass cannot be considered a monolithic one. So in this case, laminated glass of 2 × 6 mm is bending more than 10 mm monolithic. No surprise. Here, you see? So this is -2 mm because it's bending on the outside. And here is 5 mm because it's bending inside. What is happening when we take into account wind load? Wind load is very small, but you get the wind blowing here. So for an outer glass, it will be a combination of this force versus climatic force. And that is why in the end, instead of -2, we'll be having 5 mm here. And of course, the pressure starts to affect the gas inside of the IG unit. So wind plus climate will cause the inner glass to bend much more. Actually, that is quite easy when you draw the vectors of your force. Is that understood? Okay. Let's talk about triple IG unit. For a triple IG unit, the situation with the climate loads is not that good, because you have 3 glass. Can't paint it good enough with my mouse. So you have 3 glass. Like this. Now, what is the climate loads? Expansion of both cameras, so here, here, and the middle pane, both forces are more or less equal. So middle pane is under no stress. It is perfectly good because it's equally pressed for both sides. But gas needs to expand. In the double IG unit, it can expand both ways. So both glass can bend, so the pressure on each individual glass is less. On a triple IG unit, you have the different situation because middle glass is not moving. So each individual glass outward, they are bending more. And that is why in the climate laws, you will be having more bending on triple IG unit than on double. Be careful with that when you're designing your IG units. Now, please let me know if you understood me or not. Because when I receive no questions, I have no idea how well you have received the information. Okay, some comments. Yes, I take it as a good one. Let's see one more example. And this is the calculation of high-rise facade building. What I want to focus on in this one, we will not be discussing it a lot, but please take a look that in this circumstance, you get much higher stress on the glass. For example, in this composition for this size, the outer glass should be tempered or heat strengthened because the load is more than it is allowed for a normal glass. Obviously here it is tempered, so no matter. Again, this is a very high tower, high-rise building. And under maximum load combination, under the worst load case, so wind plus climatic, take a look at the deflections of the glass. 32, 27, 22. The deflection here is actually much larger than the spacer, but they are all in one direction. Should we care for those deflections in this case, in this calculation? No. Why not? Simply because this is a very short time load. We need to care for the stress. So how much your glass will be bending for 3 seconds, we don't care. If it will be returning to normal afterwards. Everything is tempered here. Why should we care ever? No. We're good. It's good. So again, this is as an illustration of what is important in the to see in the different combination of a calculation parameter.